Thank you for coming. My name Sindre Breda, Norwegian guy, working in an American company called Graphistry, where we do graphs. And I'm going to talk about looking at your data in graphs without using a graph database. So who are we? We're an American company. Started back in 2014. We're ish 15 people spread across the world, so remote first. We create a software that sits on top of your data, where you can send basically anything into it if there's a connection between the data. So that's what I will show you. We have our key customers are government, because we do a bunch of data. So if you have a lot of data and you want to visualize it, you want to analyze it in graphs, we do it. So what I'm going to start talking about and show you is a project we did back in 2020, and that's where I came in and learned about this. It's basically COVID hit, and everyone was like, okay, what are people on Twitter saying about it? How can we analyze the communities? Who's talking about what? So you have all these tags, like that's a campaign, that's a campaign, that's a campaign. How can we find who is talking about the same things? Are there bots doing this? Or are there actual people behind it? So why do you want to go into graphs? For all of us that look at data, this is normally the way we do it. We have a spreadsheet, and people love spreadsheets because it's good. But when you come to the point of having 100 million to 1 billion rows of data in your spreadsheet, it's kind of hard to see the connections. So that's where we go into this, and we will see how it goes. So yeah, everyone's seeing it? Awesome. So what we did is take that spreadsheet of just users and their tags. Like that's a user that's been talking about COVID 15 times, Trump 10 times, China 15 times, whatever. And we cluster it, basically. So every node here is a user and what they've been talking about. So it's quite neat to see like the communities. So you can go and watch, okay, these guys are talking about QAnon, hydroclox, yeah, I won't try to say it again. And what you could do with your graphs at this point, okay, we want to color it. Now you see it pops out, because we're looking at what nodes are actually talking about QAnon. Where are they connected? And you see there's a couple of communities in here. Down here, and some people down up here as well. So it makes it quite easy to see where the people talking about QAnon lives in this ecosystem of all the Twitter messages, basically. So when you then go deep down, dive into it, you say, okay, this guy, and he's talking about that, and this guy is talking about it, and the connection here I'll talk about in a minute, but it's the similarity between people based on what they're actually talking about in the tags. So where GFQL comes in, it's basically, you have this, we're starting here, and GFQL is the query language you're running on. So basically you're saying, oh, the last slide or graph I showed, we're taking just coloring on the nodes. But I want to see, okay, who is 1 hop out from that node, or 2 hops, or 3 hops? So we can do the same thing. I'll just select a node, and yeah, I'll create a set. QAnon 1 hop. And I'll paste in, yeah, we'll do 2 hops. So we'll have this. That's not the node, that's the node color. So we'll basically go and say, okay, I want the nodes, and I want anyone with a tag of QAnon greater than 1. So we'll create that set. We get that in our collection, and that should, if everything works out great, yes. So now you see all the nodes with a tag of QAnon greater than 1, and everything else is black. But we want more. We want to see not just the node, we want to see also who else are like connected. So we'll add, this. That's not working. I'll show you later. I'll get back to it. So basically, we could take it a hop out as well and see who's connected in a hop out. So that's where we're going here. Now you have like you see your yellow ones, and all the purple stuff here are the people that are 1 or 2 hops connected outwards. So basically, that guy talks about QAnon, and these guys talk about something else, but they're connected through another topic or another guy, basically. So it's great for seeing and knowing, like, I don't need to focus on all the black nodes because they're not talking about or talking about what I actually want to investigate. So yeah, we're back here. It's easier to see what's happening in this tabular data once you have it here. So yeah, that's the short intro to why graphs. And my goal here today is having 5 of you guys thinking like, I might have data that is good to present as a graph. So that's my goal. So once you come to that point of saying like, okay, everything is a graph, I'm thinking in graphs, and you're visualizing and you're seeing everything is connected, how's that? So you'll get to a point where you think everything is a graph, but this is not a graph, this is a chart. And in Norway, at least in Norway, everyone's like, when you're talking about graphs, everyone, hey, make a graph of something, and they're talking about this. This is not the graph we're looking for. So saying that, everything is not a graph, but this is a graph. As developers, I'm guessing you have either like Apache logs or any log, basically, where you have some sort of source and destination. A user logging in is a source into a destination. And you have that probably in a database somewhere, but yeah, it's a relational database, I guess. I hope you store your logs somewhere. So that's when you come into the point of like, okay, how can I build a graph of what I'm looking for? What are the questions I want to ask? And that's where the edges comes in. So a graph is basically a node and an edge. And you can either put all your information on the node or you can put information on the edge. So basically you go user, connect a node's user, and you have like, in your edge, you can have information about like, where did they meet, when, whatever. So that's how you're asking your questions. So in this example here, you have a user, he owns an account, and that account is connected to a wallet. And how are they like related? Because you might have a different user account where you can see, they're signing in from the same IP, they're signing in from the same area, they're doing the same stuff. Could this be the same user having two accounts, for instance? So it's really, really good to do graphs for a number of cases. My background is as a police officer, so that's where I started working with graphs, because I was investigating hackers for the Norwegian police. So basically, we had a lot of data, and I went to my analyst team and said, "Hey, I have this connected, or like this spreadsheet of source and destination. There's 100 million rows in it, or 100,000 rows, I think." And they're like, no, we can't visualize more than basically 100 connection, or our system breaks. And then you go, okay, I need something else. So that's where I came to know about graphistry, basically, because they can do it on GPUs. So for cyber and for crime, it's good, because you have people doing something and another guy doing something, so it's quite easy to see who's doing what and are they doing the same things. And it's also really great for a bunch of other stuff as well, like finance and supply chain. So we have a bunch of customers doing it for basically tracking and knowing what they're talking about in their documents, because then we're going into the AI stuff and RAG, but this is not the topic of the talk, but basically having the knowledge of what you know. So if you have a bunch of policy documents, does this document talk about something? You can tag it, you can have it, and you can visualize it. Okay, these are all the documents I know that talk about the same stuff. That could be a graph. You can have, instead of user, you could have document, and it talks about topic X, and that document talks about topic Y, and all the documents are connected. Maybe you can make one document out of a lot of documents instead. So that's as well. So you can do scoping, and you can do patterns and outliers, and that is the fun stuff, for me at least. Think about a set of logs of people signing in or trying to sign in, or basically a DDoS attack or your network. If you have all your user and your user activity, you can do this, and you can say, okay, this group, we can cluster all the activity based on the users. Like normally he signs in from that IP, doing that, connects to that machine, checks that file, whatever. And then you can do your algorithms on this stuff and find out, okay, what's the outlier? What does not fit into my organization? Is there something that is not supposed to be here? And we did this a couple of years ago, because there was a competition that you got a huge data set. I think it was like 2 billion rows of data of seek logs and connections and whatnot. So, and the objective was reduce the amount of alerts an analyst has to look at. So given that you have a million alerts, how can we reduce this? And we went on the path of clustering. So basically, we're doing the one down here. Taking a node, and it's like you have the source, you have the destination, and you have some sort of description. And then you take and look at that node as a separate entity at all, and then you do your similarity matching. It's like, are there other nodes or rows in my spreadsheet that are similar, and how similar are they? So that would make a connection between that node and that node. The connection is they're similar as, like, in a value of 0 to 1, like they're 70% similar. So, and that's just based on the source, destination, and a description. And you can highlight like the critical players. One algorithm that is widely used in graph is PageRank, for instance. If anyone knows that, highly connected nodes. You can get super nodes because everyone is talking to this guy. This guy is super important. And when you look at Twitter data, for instance, one influential guy back in the COVID area was Trump. He was big on Twitter at that point. So he was like this super node because everyone was retweeting Trump. So he became that big node. And you can take that, okay, what if we remove the big node? Does everything fall to pieces if we remove one super node in our data set? So that's when you can see like who are the people to talk to. So if we mapped everyone here, like who knows the most guys, who's big on GitHub, who does the most valuable commits, you can say, hey, I want to go talk to that guy. He's the guy to talk to. Sorry for everyone's eyes. I can see you better now, a little bit of white. And we're back. So yeah, GFQL. Is it yet another graph query language? Yes, no, maybe? It lives in the Python. It lives in Python. So it's open source. You can just pip install everything. So when you go back to graphs, back in 2010, Neo4j, which is like the big graph vendor, or graph database vendor, version 1.0 came out in 2010, I believe. So we're like, it's been 15 years, and things have happened because a lot of database. I'm guessing none of you have all your data in one type of database. I'm guessing you have something in Redis, something in Databricks, something over here, something in Azure. So you have a lot of places to go look. And traditionally, if you wanted to make a graph, you would have to add another database and send your data into a new database. More maintenance, more pipelines to handle, all that stuff. So basically, what we think and do is, as long as you can get it in a tabular format, then you can make a graph. So, and that's where it comes. So you can have it basically in an embedded architecture. We sit on top. We can talk to any API, whatever. So, and we can load it, and you can basically do it a lot faster because you can do it on GPUs. Because GPUs are great at this sort of stuff. I think it was back in 2018 or 19. NVIDIA did a smart thing where they made a Python library for their CUDA, or CUDA language. So you could program on the GPU and talk to the GPU using Python. And if anyone, basically, if you've ever done any data analytics on the tabular data, you probably use pandas, or know about pandas, or polars. And then you had QDF, which is basically the NVIDIA version of this, where you can go, I'm doing this on my CPU, I need more speed, let's just move it to the GPU and have basically 10,000 cores instead of 8 cores doing my calculations. So then you got a 10 times speed up. So that's where you go. You can do this without creating a new database, just load your data in a data frame and have it on your GPU. So basically, it lies on the compute tier. So you have your databases, any Databricks, Spanner, Neptune, Neo4j, or CSV, or an S3 bucket, whatever. As long as you can turn it into a data frame or a CSV or like that, if it's a data frame, you can run basically graph queries on it. So we're not trying to be yet another database because there's a bunch of them. Why go that way? Why not sit on top and make everyone make graph query language available for everyone, basically? So that's where the Kraken guy up in the corner comes in. He has arms. He can reach out everywhere. So that's the thing. So yeah, how to start then? You can just pip install. As long as you're in a Python environment, pip install, and just like pandas, DuckDB, it's open source, just go for it. So ideally, you would like, what if you have a data set that's small? Like maybe you have a data set, 1 million rows, 100,000 rows, 10,000 rows. You want to visualize it, but you don't want to put it in the database because it's a one-off thing. Maybe you're getting something shipped, like sent to your email, one log, whatever, and you want to see, okay, what's actually inside of this? I want to visualize it as a graph. I want to go do graph stuff on it. So that's the thing. Like, you don't need another database for those small data sets. And that's great for doing like proof of concept stuff. You just want you make a dashboard of something where you want to visualize your graph, as you saw. This image here is quite neat to show people how things are connected. And you want to do that on like a small data set you just got in your hands, and you want to do it. You want to visualize it, or you want to do queries on it. So yeah. So that's the thing, like, and as I said, like, graph tasks are not fully connected to a database because you can do it without having a database. So why do two systems when you can have one system and just do the compute on top of your systems? So that's the thing. When you go there, and me as a like not the most technical guy, but sort of technical, back in the days when I needed to see my data, I would go to one of you guys and say, hey, could you help me extract something from your database? I do not know SQL, or you know SQL, you know that language. Could you help me get basically this data out? And now you can say, here's your CSV file, just plop it in yourself. So that's the thing. Like, GFQL, it's quite familiar as a language, because you have it you can do it in a data frame, and we love data frames, and at least we love GPUs. So it's quite easy. You have this data set where you have, as I said, like your data.csv. It contains at least two things. You have a column of source and a column of destination. Then you can just load it as a data frame. And if you want more speed, just do the qdf.readcsv, and you will have it on a GPU. And it's basically, it fits into any PyData ecosystem at that point. So you can do OpenAI, Rapids, Arrow, all the columnar stuff. So think of your data set where you had people connected to each other. So this is the non-graph way of doing it. If I wanted to see if a person 1 is connected to a node, or is a type called as a senator and is connected to that, and their values are X, Y, Z, it's getting quite like hard. If you want to go basically from that guy 3 hops out, you need to do a lot of joins in your data sets. So how do you go and find who's connected to who and do the join easily? You can end up getting all these long SQL or pandas queries on it. In the graph world, you would basically do it like this, where you have, so Cypher is Neo4j language, where you go, okay, I have this node, and it goes directionally to another type of node, or to a node where it's the senator and Pelosi. So you're getting to what senator knows both Pelosi and Schumer, basically. This is the easy way to do it, because you just it's very descriptive as a language. I want to start from here, and I want to go in that direction to any person that is a senator, and I want to take the person going in again to me. So that's where the graph query language comes in, where we go. So we're trying to make it seem familiar for everyone and easy to use and descriptive, because you're basically just talking about how you want to transform your data and how you want to look at your data. So GPUs, it's not just for Bitcoin and LLMs. CPU. In the CPU mode for GFQL, it's a single-threaded pandas. It's quite okay, and it's columnar. The data is columnar. So instead of searching, when you're searching your data, you're not searching row by row. You're searching column and then fetching row, basically. That's the pandas in columnar way. So if you have like small data set of like starting from basically 100 edges to a 10 million edges, CPU is fine. But it's when you get bigger. Think if you have 1 hour of data for everyone signing into your app, it's okay, you don't need a GPU because that set is small. But once you're going, hey, I want to see the last week or the month or the year, then you can get the benefits of doing this on a GPU. So that's why you need an NVIDIA GPU basically, and you can just pop it in and run your query on a GPU, and you get course. So basically, a bigger graph and a bigger, if you have a bigger GPU, the more money you have to spend, the bigger you can go, basically. Bigger, more is better. So bigger graph, and you can have more speed. So basically, you could go, if you have more than 10 billion edges, and billion, it takes, talking with Americans, billions is for Norwegian, it's the same as a milliard, basically. So it took me a while to learn the difference. So basically, if you have 10 billion edges in your data, you benefit a lot from doing this on a GPU and doing your calculations on a GPU. So this image, it shows basically benchmarking for a CPU versus a GPU and the query time for doing on a data set of a social network, basically. Who knows who is friends with that person, who is friends, or who are friends, basically. And on the CPU, you can see at some point, if you go 1 million edges, the query goes, it takes roughly 1 second on the CPU. So that you can wait 1 second for your query to finish. That's good. But it's quite fast. You go above like the 1 minute mark. And if you're doing more complex stuff, you can click enter and you can go grab a cup of coffee, come back, watch, is it done yet? Nope, sit down, go grab another coffee. So for the GPU stuff, you can go speed up. So you see one T4 GPU, which is it's quite cheap one now. I think it's like, if you can buy it, basically, it's $500 or something. So it's the same price as a high-end CPU, basically, for your machine, or you can have it in cloud, basically. And it's not that costly to do this. And that's when you can see in the same amount of time, like the 1 second mark, from going from a CPU to a GPU, I can do 100 million instead of 1 million edges traversal. So the speed up and like the multi-threading, basically, because once you have those GPUs, you have cores. And a GPU, as I said, basically has 10,000 cores to do this stuff. So you can look at every core can handle 1 row at the same time, or path. So you can have a lot more and a lot speedier, basically. So for $1.53 or 0.53 cents an hour, you can run this, basically, and have a GPU in any cloud provider. So you get a lot of speed up of going to GPUs. So yeah, you can do 2 billion edges in less than a minute, and in less than a minute, it's quite good. You can probably wait a minute for a task-intensive query on your big data set. It's when we go to the hour mark, it's painful. So yeah, we talked about this graph, and I'll show you how to make it basically, and how easy it is. It's just a CSV file of users, as I showed you. It basically, you have a user ID, and we have done the tedious task of tagging all his tweets and collecting it. So the pre-work is done. So you have a tag. Basically, it's a user and all the tags, all the stuff that that user has tweeted about. So basically, you just go graphistry.nodes, and if you want it on GPU, you do QDF, read CSV, and you select the column in your data set that is your node identifier, basically. And then you do the magic, basically, and that's the UMAP algorithm. A UMAP, without going too technically into it, basically it takes what your data and it says, okay, how are things connected? Could I make a community out of people talking about the same stuff? So that's what we're seeing here. And it's, so basically what you're doing is you're loading and you're shaping and analyzing, throwing some AI on it, and you're visualizing it in one line in your Jupyter notebook or wherever you want to do it. So it's quite easy to do it, to get to the graph you see here. And so that's the thing. Why you don't own a GPU? You say, okay, it's okay. You can either, or you don't have a GPU in your machine. So that's the use case for that is basically you're sitting on your laptop. You don't have a GPU, but you're doing some tasks that could benefit from having a GPU. And that's like, so I was talking about, you have this query, you have an ETL where you're doing stuff, and you're getting to the point where, I just need for this one task, I need a GPU. I don't need it for the full pipeline because that's good. I just need for one task. Why not have a machine spin up? You can just send your data remote to that machine and get it back and do the calculations remotely for just that small procedure you want to do that is time consuming, because it could take hours on a CPU and minutes on a GPU. So you speed things up, and you can just ship it and upload it to a remote location. Okay, so everyone's doing LLMs. Everyone's talking about it. Everyone's using Copilot, whatever. And how could you do this? And like, who writes the queries? Does it have to be a tech-savvy guy doing this? Or could it be an end user? Basically, any person having access to a computer, they want to talk to a database, they want to do this stuff. Do they need to know how to code? And that's the thing, like you could do, using your LLMs, you can do a connect and you can have your LLMs talk to your database. And your LLM could know how to do your cipher, how to do the queries, how to run your algorithms. Because we're talking, a bunch of people like, what is vibes coding, as you say? Like vibes coding, everyone's doing it, and no one's searching Stack Overflow anymore. That page is dead. Everyone's just going into their GPT, asking the questions, copy, pasting, tweaking, all that stuff. And you can do the same for investigations, as long as you have your data. But you might not want to ship your data and just upload everything into OpenAI. But you can, so why not have your own sort of environment doing this? So that's why we made Louis, basically, because Louis, as I showed with the sitting on top, this one. Why not have your LLM know your data? Sit here. Basically, be able to do this job for you, query your tasks, and have, okay, I want to grab. Well, why not just ask your AI or LLM to say, hey, I want 100 rows from my database talking about sign-ins, basically. give me the last 10 sign-ins to any data in this database and make a graph of it. So that's where we went with it on the LLM path. We're trying to say, I don't want the end user to have to know this, have to know how to code. Why do they need to code, basically? So, yeah, don't share this because basically my boss said, hey, Sindre, we're doing this CTF, and we're trying to beat this. If anyone knows Splunk, or use Splunk, heard of Splunk? Yeah, awesome. So they have this thing called Boss of the SOC, and it's a CTF, basically. So you get a bunch of questions, you have to answer them, and using Splunk. So you need to know, how do I make this query? How do I analyze my data there? So my boss got the brilliant idea of throwing Louis on that and see, could an intern with our tool beat me? So as he says, 10 years experience working criminal investigations and analytics. Could I do this? I'm not a Splunk expert, so I had to learn a lot about Splunk at that point. But could I even compete, basically? We'll see if we have sound on it. Do we have sound?
A few moments later.
So yeah, I will forever be known as the guy that lost to AI. So behind the scenes here, that's the fun part. You can, because you're doing it on GPUs as well, you have GPU data frames. So you're spreading the task. Everyone can, you pop open machines or virtual machines, and everyone gets a question basically to answer. So yeah, I'll get that. So that's the fun part in the future. When you can do this, you can have your AI knowing your data, and you have your AI knowing how to do graphs. Why not just ask it, hey, I want this data, and could you also please present it as a graph for me? So you can do all this pipeline stuff without having actually needing to know any coding, basically. So okay, I had a goal, and I'll stand by it. I wanted 5 people out of you guys to think, I might have data I can use, or where a graph could be useful. So I'm not going to put you on the spot and like show of hands or anything like that, but oh, there's one guy. Great. Ah, one more. Awesome. So yeah, that's the thing. Like I hope I have 5 of you, at least 5 of you, thinking, but you might not do it today. It might be in a week or 2, or at some point, you might come into a situation where you say, this could be helpful with the graph, because I don't know what type of data I have. So I'll give you some examples of cases where I started seeing graphs as highly useful, and at least doing the UMAP stuff I was talking about. I was working a case where we had a bunch of communications, basically, who's been sending emails or chatting with who. So when we we basically had the tedious task of going through emails of all of the emails of a person, but who, and we saw like, okay, there's 10,000 emails to read, and we know what we're looking for. Like we have some topics that we were searching for, and we ended up tagging each email. So once you have that, you can do some clustering, like what emails are similar, basically. Are there emails not based on keyword, just like keyword searching, because that takes some time and you need to think of all the keywords. But if you have something you're searching for and you have all the data clustered and you have tagged it, you can do basically, instead of this being tweets, what if you had this community down here? This could be a cluster of emails basically talking about the same thing. And when we're talking about that, this cluster up here, you don't need to look at it because it's not talking about anything you actually want to talk about, because you see the yellow dots, that's something mentioning something I need to know more about. If it's fraud, if it's insider trading, whatever, you have that ability to basically, this is a cluster, so I need to go, I want to dig into this group of people or data. I don't have to look at this, but I want to look at this. It could be relevant, it could not. So that's like one of the use cases I see and use fairly often. And for also for your network logs, you have a sign-in, or you have your day of activity, basically. A full day, all the people signing in, connecting, and as a spreadsheet, it's hard to look at. But throwing it in a graph, you get this image of saying, this group of people are normally, they're living quite happily over here. But here's another group it shouldn't be here, basically. These are the outliers. So they're basically, once you're thinking in graph, you get this sort of, your brain gets a little bit fuzzy because you see connections between everyone, who knows who, and all that stuff. So that's the thing. Hopefully, I've inspired some of you to start at least going into your data and seeing if I can get more value looking at it in a graph. So, how can I get you started doing this? Our product is open source, so you can, for all the Python stuff, just pip install it and you have it. It's a GitHub, whatever, and you can just read it, start working with it, and you don't need to buy or pay for anything, because you can just sign up for our free GPU account at hub.graphstream and you can get the visualization stuff. So you can do that, sign up, get an account, and just start playing, basically. So, small disclaimer, given that it's our server, don't send all your sensitive data to us. We don't want it. So be careful about that. That's your task, basically. But it's out there, so you can just sign up and you can have an account and start playing around and doing. Basically, you can do this. If you want to, just try it, play with your data, upload it, and you can sit here and analyze it and see value. You can join our Slack, community Slack, and ask us questions. We love the questions, and we get there's a bunch of smart people out there asking us questions that makes us think a lot. And if you want to get beaten in your day-to-day work and by an AI and want to try that out, just contact us on that as well. Louis is in early access, and we want people to join us in that, so and help us make it even better and make it valuable for everyone. So we can chat about that if that is something valuable to you guys. So yeah, I've been talking a lot. Are there any questions from people? Anything you want to know more about? If you want to ask it in the open, or we can do the questions down here for everyone. So yeah, we're hiring if there's the right guy out there. Mostly U.S. people, so I'm the only one in Europe. So it would be nice to have a friend. So yeah, question.
Back in the day, there was Friendster.
Yeah.
It was going slower and slower and slower because they were doing the whole graph relationship thing. And that wouldn't be a problem today, right? It's so much faster.
Yeah. So the question, if I heard you correctly, like Friendster, they were doing graphs back in the days, and everything got slower and slower and slower. So yeah, now you basically now throwing this on a GPU, you can have, as I said, we can have that full network. Basically, the Twitter data set I showed, it consists of 160 million tweets, and everyone who's retweeting and all that, and you can search it like that, snappy snap. So that's no problem anymore. Yeah.
How fast can I get a demo that, like you showed, up and running and share with my coworkers?
How fast? Doing this one or doing something like that. Basically, notebook, pip install, have a CSV, read, and sign up for an account. How fast do you type, basically? So you could probably get a demo up before. If you open your laptop now, you can probably have a demo up by the end of me walking down the stairs now. So it's fast. Basically, just sign up for an account, get your API keys to your account, and sign in. Have a visualization. So it goes fast. So yeah. Great. If there's no more public questions, I'll thank you for your time, and I hope this had some value to people. And now, are there 5 people now interested in graphs? Show of hands, 1, 2, 3, yeah. I made it, yes. Awesome, my boss is going to be happy with me turning 5 people into graphistas, awesome. So okay, thank you everyone, and stop by, grab some stickers, ask me questions, and yeah. DM me on LinkedIn or wherever, and join our Slack for more awesome graphs. Thank you.